Okay, so in this video we've got a quick introduction to the antiderivative formula or the integration formula. Whatever you call it, it doesn't really matter. First of all, we'll look at the derivative formula. Now you guys have, finding the derivative has become second nature, but at some point I taught you a rule. That rule was if f of x equals ax to the n, then f dash x equals na to the x, n minus 1. Now a quick example, if f of x equals 4x to the 3, then f dash x equals na, so 3 times 4, which is 12, x to the n minus 1. Now that n minus 1, it starts off as a 3, so n minus 1 is going to be 2. Now again, you guys can do that pretty quickly. You guys can immediately see 4x cubed and tell me that's 12x squared. Similarly, with this integration stuff, you will eventually be able to do it without thinking a whole lot, but to begin with, we're going to need a formula. Now that formula says if f dash x equals ax to the n, so you've already been given the derivative. If the derivative equals f dash x, ax to the n, then the integral, or the original function, is going to be ax to the n plus 1 divided by n plus 1. Now you can see it's just the reverse of this. We did an n minus 1 here, we're doing an n plus 1 here. Then we're doing a divide by n plus 1. The reason we divide by n plus 1 and not n is because our original function, which is here, actually was an n, or that n there, the original was actually n plus 1. So the way that it works, if our original function, if our derivative function is equal to 12x squared, then our original function will be equal to 12x to the 2 plus 1 over 2 plus 1. Now that's going to be equal to 12x to the 3 over 3, which is going to be equal to 4x cubed. So in the beginning example, we went from 4x cubed, we found the derivative, 12x squared. In this example, we went from 12x squared to the original 4x cubed. That is a quick introduction to using the antiderivative formula.